Hey everyone, today we're going to be taking a look at how we can solve integrals in the form of f prime of x over f of x. And this is part 2 in this series. And part 1, we discuss these problems based on non-trigonometric functions. So basically just like x to the power of 6, x cubed, log of x. But in this video, I'm mainly going to focus on these problems in relation to trigonometric functions. So if you haven't seen the first part, no worries, I'll link it in one of the two corners on your screen. And I suggest you go solve those problems first so that you're a bit more equipped and have a bit more practice with this theorem. And after that, come back to this video and we can go over some harder problems that involve trig. But if you're still here, just a refresher that this integral f prime of x over f of x dx is equal to natural log of absolute value of f of x plus c. And this is only true when you have the derivative in the numerator and the actual function in the denominator. And that's all there is to it. Hopefully this was a bit of a refresher from our last video. And let us get started with some practice problems. Alright, so let's start with our first problem. We have integration 1 minus tan x over 1 plus tan x dx. And if you want, you can pause this video and give this problem a go, but I'm going to go over the solution right now. So what many of you may think to do first is to just directly apply this formula. And okay, let's try applying it. So we have to assume that the denominator is the original function, right? So I'm just going to set f of x equal to 1 plus tan x. Meaning that when I take the derivative of this, it should be equal to the top, since this is the form that we're trying to get this integral into. So we can just apply this formula. So if we take f prime of x, that is actually equal to secant square x. Just secant square x. And we see that this is not equal to the numerator. So we can't apply this formula directly. We need to somehow manipulate this integral in order to apply this formula. So in that case, this is also another hint. Whenever you're applying this formula right over here, it's very rare that you'll apply it head on. You may have to change this integral a little bit. You may have to simplify it. You may have to use some trigonometric identities as well. And then you will reach to a point where you can indeed apply this formula over here. But first, you need to simplify, and then you can apply this integral. So let's actually simplify this. The most noticeable way of simplifying this is that we know tan x is sine x over cos x. So tan x is 1 minus sine x over cos x over 1 plus sine x over cos x. And dx, that stays the same. In this case, let's simplify it a bit more. Let's take common denominator for both top and the bottom is cos x. So we have cos x minus sine x over cos x plus sine x. This cos x and this cos x, they cancel each other out. And now this is what we are left with. All right. So now I think we can't simplify this any further. So now let's actually try this formula. So let's say that f of x is equal to the denominator, because that is what our theorem says over here. That is what our theorem says over there. So f of x is equal to cos x plus sine x. And f prime of x is equal to minus sine x plus cos x. And this indeed matches exactly with our numerator, meaning that we can apply this formula. So you see, we have to kind of tweak the original problem a little bit in order to apply this formula. But let's actually solve this problem fully. So now in this case, let's rewrite our integral. Natural log of the original function, and the original function is in the denominator. So that would be cos x plus sine x. Close that absolute value and our plus c, and that is our final answer. All right, now on to our second problem. This one's a little bit tricky. So integration sine x minus x cos x over x times x plus sine x dx. And I'm going to go over the solution right now. So first off, let's actually see if this automatically means that we can apply this formula. So if I say that t, and this time I usually use u-substitution, because I'm going to assume that u is the original function, aka the denominator, and I'm going to just find u prime. And I think that makes it a bit easier. In the previous problem, we just used f of x and f prime of x, but I don't think that's a good practice. I did it for the first problem because we're very familiar with f of x and f prime of x, but we do need to use a little bit of u-substitution in the upcoming problem. So it's better to understand how to use u-substitution in these problems right now. So in this case, I'm usually used to using t, but we can use u for this demonstration. So we have u is equal to the denominator, the original function, which is, I'm just going to simplify it. I'm going to expand that. So x squared plus x sine x. I'm going to take derivative of both sides. I get 2x plus, and then I apply the product rule, but we can stop right there because you could apply the product rule if you wanted to, but even if you apply the product rule, you're not going to get this is equal to this. That's just not going to be possible. In other words, you need to simplify this integral first, and then you can apply this formula. So in order to simplify this integral into a way that we can actually apply this formula is a bit tricky. But here is what you have to do. So you have to take integration, of course, and I want to cancel out the denominator with something in the numerator. That means I need to take this part, x plus sine x, and put it in the numerator somehow, or make the numerator so it has a x plus sine x somehow, because that's the term I want to cancel out. And in that case, we're going to add x and we're going to subtract x from the numerator. So how does that look like? So we're going to add x, so we're going to have x plus sine x, and we're going to subtract x minus x cos x over x plus sine x dx. First, I want to take the x out of these two terms. So I'm going to do integration once again, x plus sine x minus x, minus x, 1 plus cos x over the denominator x plus sine x dx. Let's take that up here. Now I'm going to split this fraction into two parts. I'm going to take this part and I'm going to take this part right over here. So this means that I'm going to have two integrals actually. So I'm going to have integral of x plus sine x over x plus sine x, and I think you could see where I'm going with this, plus integration of x 1 plus cos x over x times x plus sine x, and dx right over there. That's a bit small, but that's dx over there. Now we can start simplifying. So I know this and this will cancel out. We have integration 1 over x dx. We know that, lucky for us, plus integration, that and that get canceled out. So we have integration 1 plus cos x over x plus sine x dx. All right, and now you could see a little pattern we have. So let us simplify that. We know that is natural log of x. And in this case, we know that we can apply this formula right over here. How do we know that? This is why. Over here, I'm going to say u is equal to the denominator of this, so x plus sine x. I'm going to take derivative of both sides according to the rules of u-substitution, so I go 1 plus cos x, and that is indeed equal to our numerator. So we can actually apply this formula now and say that this second integral is equal to a natural log of the original function, so the denominator x plus sine x, and of course plus c, and that is our final answer. So this problem was definitely on the tricky side, mainly because we had to find what we could add, what we could subtract, and ultimately our goal was to come to this point. Alright, so this is our next problem. We have integration tan x over a plus b tan squared x dx. So in this case, let's simplify first, and then let's apply this formula. So I'm going to simplify tan x into sine x over cos x. So sine x over cos x over a plus b sine squared x over cos squared x, and then dx. So we have integration. I'm going to simplify the denominator, so I'm going to keep the numerator the same. I'm going to simplify the denominator. We have a cos squared x plus b sine squared x. I'm going to bring this cos squared x up top, so times cos squared x dx. I'm going to bring it right over here, equals sine x cos x over a cos squared x plus b sine squared x. At this point, we can't really simplify any further. It's in its simplified form. I can't apply any trigonometric identities that would help me, so I'm just going to apply u-substitution and see if I can actually apply this formula over here. So I'm going to say let u equal the denominator, so a cos squared x plus b sine squared x. I'm going to take the derivative, so 2a cos x minus sine x. I'm going to put that minus sign right over here. I'm applying chain rule for this one. And then we have plus 2b sine x cos x and then dx. I'm going to take this cos x sine x out of the both terms. So we have du equals sine x cos x minus 2a plus 2b dx. I'm not going to take the minus 2 out because minus 2a and b, they're constants. I'm just going to keep them all together so that later on I can take them out of the integral. So now I see that in the original integral right over here, we have the sine x cos x dx, and here we also have the sine x cos x dx. But I'm going to isolate sine x cos x dx, so I'm going to divide both sides by this term right over here. So sine x cos x dx is equal to du over minus 2a plus 2b, like that. And this way I could substitute this into the integral. We're going to take this down here. We have integration of this whole thing is going to be equal to this right over here. So du over minus 2a plus 2b. And then integration right over there. That is just the numerator. And then the denominator is just going to be u, because that's what we substituted for u. So we're going to have u. I'm going to take this outside because it's just a constant, right? So that's going to be 1 over minus 2a plus 2b, integration 1 over u du. This is simple to integrate, so we have minus 1 over minus 2a plus 2b, natural log of u. I'm going to replace u straight in, so a cos squared x plus b sine squared x plus c, and that is our final answer.